Hello, Mr. Dre back with another video, and in this one, as you can see, we are adding fractions. And in this specific problem, the difficulty here is that our fractions do not have the same denominator. Here we see this one is 4/6 and this one is 2/7, and we have to figure out a way to add these. Now, if this was 4/6 plus 1/6, that'd be easy because we could just add 4 plus 1 and get 5/6, right? But we see the difficulty and the extra work comes because they have different denominators, right? So we're going to show you two ways to go about doing this. Both ways they're going to get you the same answer, but there's two different ways. There's a lot of different ways to do it, but we're going to show you two ways to do it, and then you can decide which one works best for you. So the first way, this is probably the most traditional way, is we're going to set up 4/6, and most of the time we set it up vertically, going up and down, right? So 4/6 plus 2/7. So as you can see, the hard part here is that the denominators are different. So what we want to do is we want to try to find equivalent fractions for both 4/6 and 2/7 that have the same denominator. Basically what we're finding is the least common denominator, and we're going to do that by finding the LCM, or least common multiple, right? So we take the two denominators and list them. We usually put them down here, 6, right, and 7. And what we're going to do is we're going to list out all the multiples until we get a match, right? So 6, and right now I'm just listing my times table. 6, 12, 18, 24, 30. I usually do like the first 4 or 5. 7, 14, 21, still no match. 28, 35, still no match. I'm gonna go a little bit higher on this one. 36, 42. The next one is 42, so we finally have a match way at 42. So what we're gonna do is we're gonna change each denominator to this least common denominator, or LCM, right? So 42 and 42. Now, here's what we have to do. We have to find an equivalent fraction, 4/6, that changes into 40-seconds. So how did we go from 6 to 42? Well, we multiplied by 1, 2, 3, 4, 5, 6, 7. We multiplied by 7. So to keep fractions equivalent, what we do to the bottom, we do to the top. So we're going to multiply this 4 by 7, and that's going to give us 28, right? Now, same thing with our second fraction that we're adding. How did we go from 7 to 42? Well, we multiplied by 1, 2, 3, 4, 5, 6. And what we do to the bottom, we do to the top. What's 2 times 6? Well, that gives us 12. Now we have the same denominators that we can go ahead and add the numerators, right? We never add the denominator. 28 plus 12, that's going to give us 40, okay? And when we go and reduce that, because that's a pretty big number there, this definitely has the simplest form, so we're going to cut it in half, and that's going to give us 20 21st. Okay, 20 21st. All right. Now, we're going to show you a second way to do this, right? A second way. So here we have 4/6 plus 2/7. Okay, 4/6 plus 2/7. And this way kind of has, if you might see videos or pictures of this, other teachers call it a certain way. To me, that's a little bit more confusing, but if it works for you, you can definitely use it. So I'll show it to you. A lot of teachers call this the butterfly method because I guess it kind of looks like a butterfly. I don't know, right? There you can kind of see, it's 2 wings, it's the bottom of its body, and then the antennas, right? So what you do, it's actually really, really simple. What you do is just multiply these bottom 2 numbers, the 2 denominators. 6 times 7, I'll put a little X there. 6 times 7 is 42, okay? And that 42 is going to be our denominator over here, right? And then what you do is you cross multiply. See how these wings kind of make an X? 6 times 2 is 12, and 7 times 4 is 28, okay? And then all you do is just add these two antennas. 12 plus 28 plus 12 is 40. All right, and there you can see that's what we got down here, okay? Now, why did that work? Well, that worked because the 4 changed to 28. How did we know to change the 4 to 28? Well, because we know we multiplied it 7 times, right? The bad thing about this method is that this wasn't a very good example because you had to reduce them both, but this method is going to give you fractions that are really going to have to be reduced, wherein most of the time on this side you won't have to reduce them that much because you're already kind of bringing them down, although in this particular problem it turned out to be the same way, so just be aware of that. And then obviously, you know, we would simplify this one to 20 21st as well. So we ended up with the same answer, 2 different ways to do it. The traditional way of finding the LCM and then finding equivalent fractions, adding, and so on. And then this way, we're not really finding the LCM. What we're doing is just finding a common multiple of the two denominators. It's just not the least common, so you're gonna have a lot more work to do. So you're just finding any common denominator of the 6 and 7, which is just multiply them together and get, you know, in this case 42, and then changing the numerators to whatever they go to find the equivalence. So whichever way, you know, in both ways is better, but practicing, you know, one at a time and then seeing which way works best for you. Again, this was adding fractions that had what we call unlike denominators. 2 ways to do it. Hope that was helpful, and we'll catch you on the next one.